What is PN junction? A PN junction is an interface or a boundary between two semiconductor material type, namely the P-type and the N-type inside a semiconductor. In this diagram, you can see at the left side we have a P-type and at the right side we have N-type, which is connected with anode and cathode respectively. Here we have a symbol of PN junction diode. This is P-type and this is N-type. Here in the diagram you can see the PN junction is formed between the P-type and the N-type. The P side or the positive side of the semiconductor has an excess of holes and the N side or the negative side has an excess of electrons. In a semiconductor, the PN junction is created by the method of doping. The process that follow after the formation of a PN junction are of two types, diffusion and drift. As we know, there is a difference in the concentration of holes and electrons at the two sides of a PN junctions. The holes from the P side diffuse to the N side and the electrons from the N side diffuse to the P side. This gives rise to a diffusion current across the junction. Also, when an electron diffuses from the N side to the P side, an ionized donor is left behind on the N side, which is immobile. As the process goes on, a layer of positive charge is developed on the N side of the junction. Similarly, when a hole goes from the P side to the N side, an ionized acceptor is left behind in the P side, resulting in the formation of a layer of negative charges in the P side of the junction. So we can say that the diffusion current is the moment caused by variation in the carrier concentration, whereas the drift current is the moment caused by an electric fields. Direction of diffusion currents depends on the slope of the carrier concentration, and the direction of drift current is always in the direction of electric field. The region of positive charge and negative charge on either side of the junction is termed as depletion region. Due to this positive space charge region on either side of the junction, an electric field direction from a positive charge towards the negative charge is developed. There are three biasing conditions for PN junction diode, and this is based on the voltage applied. Zero bias, there is no external voltage applied to the PN junction diode. Forward bias means the positive terminal of the voltage potential is connected to the P side while the negative terminal is connected to the N type. Reverse bias means the negative terminal of the voltage potential is connected to the P type and the positive is connected to the N type. First, we will see the forward bias. When the P type is connected to the positive terminal of the battery and the N type to the negative terminal, then the PN junction is said to be in a forward biased. When the PN junction is forward biased, the built-in electric field at the PN junction and the applied electric field are in opposite direction. When both the electric fields add up, the resultant electric field has a magnitude lesser than the built-in electric field. This results in a less resistive and thinner depletion region. The depletion region's resistance becomes negligible when the applied voltage is large. In silicon, at the voltage of 0.6 volt, the resistance of the depletion region becomes completely negligible and the current flows across impedance. Now next is reverse bias. When the P-type is connected to the negative terminal of the battery and the N-type is connected to the positive side, then the PN junction is said to be reversed bias. In this case, the built-in electric field and the applied electric fields are in the same direction. When the two fields are added, the resultant electric field is in the same direction as the built-in electric field, creating a more resistive, thicker depletion region. The depletion region becomes more resistive and thicker if the applied voltage becomes larger. Now we will see the advantages of a PN junction diode. PN junction diode is the simplest form of all the semiconductor devices. However, diode plays a major role in many electronic devices. A PN junction diode can be used to convert the alternating current means AC to the direct current DC. These diodes are used in power supply devices. If the diode is forward biased, it allows the current flow. On the other hand, if it is reverse biased, it blocks the current flow. In other words, the PN junction diodes becomes on what it is forward bias, where the PN junction diodes becomes off when it is reversed bias. Means it acts as a switch. Thus the PN junction diode is used as an electronic switch in digital logic circuits.